Hello, everyone. My name is Tashwin, and we have Jingjie, Brendan, Anna, and Jay with us here today. We're from Practical 6, Group 5, and today we are here to present our database system design for our SunForge Hackathon 2025 database. So, the question that we decided to go with was a hackathon question. So I will be presenting our case scenario. So the case scenario that we came up with was that Southern Universities is holding the SunForge Hackathon 2025, which is an annual inter-university hackathon organized by our school. So it aims to bring together developers and entrepreneurs from universities across Malaysia to solve real-life problems using technology and coding issues. So the hackathon will be held over 3 days at our campus, and then one team can be joined by 2 to 5 different participants. And each of these participants, they have to register individually, then they have to join together to form a team. And then in the team, one participant will be selected to be the team leader to help the team register and to communicate with the organizers and everything. Then all the participants' details, which we will collect, which includes their full name, the university email, and their study program during registration. And then team leaders can manage their team members and also handle their submissions, like for the coding and all that stuff. So to make the hackathon a much bigger event than just a hackathon, we've decided to include also pre-event sessions such as workshops, networking sessions, and industry talks. So basically, these participants are able to go for workshops, talks, or networking sessions with industry professionals before the hackathon itself. So this session, they're open to all the participants, and there's like certain amount of time slots for all these sessions. So participants can register for one or more sessions, but they must attend at least one session, one of these pre-event sessions, to be eligible to be participate in the hackathon. Okay, and industry experts and educators are also invited to as mentors to guide the teams. So each team will be assigned by one mentor and then one mentor can guide multiple teams as well. So to make it clear, it's just that every single team will have one mentor, and every mentor can guide more than one different teams. Okay. So how the mentors help the team is by assisting them, by providing them with advice, giving them ideas and like criticism on how their product can be developed on their coding and all the other stuff. So during the final day of the hackathon, all the team leaders are required to submit their final prototype and pitch it as a team in front of a panel of judges lah. So each of the team will be evaluated by at least 2 judges, and then the judges will be giving the marks in terms of transparency, innovation, technical feasibility, and presentation quality. And then the scores are all recorded digitally, like in the database itself. And then based on the cumulative score, the top 3 teams are awarded the prizes and certificates. Yeah. So this entire database system, will be doing it using Oracle Apex because we think it's easy to access and the interface is quite easy for newcomers like us to help design a database. So by making the whole process digital and automating it, it will reduce significant manual admin overload and ensure a smooth experience for all the participants, judges, mentors, and industry experts alike. So we have created an ERD diagram, and each of these ERD diagram are able to properly track all the queries, which is listing sessions that a participant has attended, tracking mentor to team allocations, viewing average judge scores per team, identifying team with overlapping members, and monitoring participant attendance for eligibility. Yeah. So the business rules that we have created with in terms of this hackathon is that number one, each participant must be registered with a unique email and contact number. Number two, teams should consist of 2 to 5 participants, with one designated as team leader. Mentors can mentor multiple teams, but each team can only have one mentor. Judges can evaluate multiple teams, but each team must be evaluated by at least 2 judges. Participants can register for multiple optional sessions when attendance is recorded for each session, but participants are compulsory to attend for one session. Yep. And now I will pass it over to Jingjie to explain about the ERD diagram.
All right, thank you. Okay, hi, my name is Jingjie, and I'll be continuing off with the entity relationship diagrams here. So over here we have the ERD layout for our SunForge hackathon system. So first here we have a few tables for our entities. So we have participant, team, team membership, mentor, continuous holding, judge, evaluation, pre-event sessions, all those basically. We have entities that showcase the concepts used in the hackathon system. So we have participant to manage participant data, team for team data, etc. Then we also have some junction tables here. For example, your session attendance table, which consists of a composite primary key, participant ID and session ID. So this is just basically acts as a bridge between all the main entities itself. So that's for the layout. Now for the ERD diagram itself, as you can see on screen here. So over here, we have all the entities connected by the relationships. So as you can see for participant and pre-event session, they're linked together by the session attendance table. Participant and team are linked by the team membership table. Team and mentor are linked by the team mentor table, and judge and team are linked by the evaluation table. So now this ERD is normalized thanks to the junction tables here, your session attendance, your team membership, your team mentor. So just to quickly elaborate on one of them, for example, the judge and team tables over here, they're linked together by the evaluation table. So for instance, referring back to the business rules earlier, one judge can give one or multiple evaluations per team, and one team must receive multiple evaluations per table. So as you can see by the relationships there, they indicate a one-to-many and a many-to-one relationship between the tables together. Now, that's all for the ERD. So moving on to the constraints. So here's just some constraints just to maintain consistency across the tables. So excluding the defaults of primary keys, foreign keys, and having not null data. So for our constraints, we have check the length of the phone number to make sure it's 10 digits, just to ensure proper phone number formatting. For the score innovations to be between 0 and 10. So just to verify the judging score. So the size of each team must be between 2 and 5 participants, just to avoid overbooking and such. We also ensure email validation through using the @ symbol. And finally, we have only 2 options to verify your attendance, either yes or no. So next up, I'll be passing on to Brandon to explain about the SQL table.
Hi, my name is Brandon, and now I'm going to go through the SQL for creating the tables. So to start off, before we create our table, we need to basically clean the palette. We clear out by dropping the tables that we will need with the cascade constraints. So as we drop them, we can start with a fresh sheet. So to start off, we start by doing the create participant, because the participant is like the main point of our whole graph. So we create a table with the primary key with participant ID, because the ID is the unique identifier that each participant will uniquely have. Whereas their name, we put varchar2 with 30 limit. So it's for them to put in their name. Some people might have the same name, so we did not use that as the primary key. However, next we have the email, which is also in varchar2 with 30 limit. However, each participant must have a unique email. They cannot share the same email to register. So we have the not null unique following that. So other details for the participant will be the phone, university, and program. The phone is in numeric only because there are no letters, obviously. Okay, next for the team table. So we create the team table with the team ID as the primary key. We don't expect many teams, so within 3 numeric is enough. So their names is up to them, fit with a limit of 15 characters, whereas their team leader ID, which is referring back to the participant ID that they used previously. Therefore, the foreign key, yeah. So next we have the team membership table. So it's the other members. So therefore, we refer to the participant ID with the foreign key again, whereas the team ID is from the previous table, from the team's table ID. Okay, next would be the mentor table. So now we introduce new unique people. So we give them a unique identifier again as a mentor ID. And attached to their mentor ID would be their name, company, and expertise, all in varchar2 with 30 and 20 limit respectively. So next would be the team mentor. So each mentor is attached to a team. They can mentor multiple teams as well. So we link them to the team ID, which is their foreign key, and the mentor ID, which is the foreign key from the previous mentor sheet as well. So moving on next, another unique new character, new person would be the judge. And we use the judge ID with their unique identifier for the primary key. So their name and the affiliation as well, similar to the mentor one. The next would be the evaluation, which would be the next we have the evaluation, which is connected to the judge and team ID, which is the main. We've used a foreign key which references that. But then next we have the score for the innovation, feasibility, and presentation, and finally their total score, and they all adds up to the total score limit. All right, next would be the session ID, which is the primary key. Each session are unique as well, but however, their title and type, they all can be overlap. And the date time would be in date format only. It cannot be in any other format. Next would be the session attendance. Participant ID would be referring back to the participant sheet, and the session ID likewise as well. And finally, we have the attended, which is a yes or no thing. Okay, so next, moving on to Anna, which she will.
Hi, my name is Anna. I'm going to tell you about the insertion statements that we use to populate the tables. First is the participant table. It has 8 rows that we inserted the participant ID, the name, email, phone number, the university, and the course. And the next table is the team table. And we inserted the values for the team ID, team name, and team leader ID. And next is the team membership table, which has the values for participant ID and team ID. Next is the mentor table, which has mentor ID, mentor name, company name, and expertise. Next is the team mentor table, which has values for team ID and mentor ID. The judge table has judge ID, name, and the affiliation. The evaluation table has judge ID, team ID, innovation, feasibility, presentation, and the total score. The pre-event session table has session ID, title, type, date, time, and venue. The session attendance table has participant ID, session ID, and the number and the attended. And yeah, that's it for the insertion statement.
All right, and then now I will take over again to explain about the queries. So we have selected all the queries over here in the SQL file, but because it's very grouped up together, I have separated into 3 different command tabs so we can see it much better. So I'll be explaining the first 3 queries, then Jay will be explaining the rest of them. So for this one, our first query, which is a query that requires an outer join. So we came up with which participants did not attend any pre-event sessions. So for that, we require the participants' ID from the participants table, their name, and also which session they did not attend, right? So we selected all these 3 items from the participant ID. We left joined them with the session attendance table, so we can get which participant did not attend on which session they didn't go to on the participant ID, which is the foreign key towards the participant table. So and then we put a condition where the attended column is no. Then we run it. Yeah, sorry. Okay, so when we run it, we will get the same. We will get this, which is these are the participants who did not attend a session. So these participants did not attend these sessions. Yeah. Okay, and then that will be for query A. For query B, so our query will be the query that we were required to do was a minimum of 4 table join with a group by a function query, right? So the query that we came up with, what is the average total score each team received and who are their mentors? So this one requires team name, mentor, and also the score. So we selected team ID, team name, mentor name, and total score, and also as average score. And then so from team, the total score will be like from multiple judges, it will take together and then round it off, and then like we get an average score from all the mentors together. Also all the judges together, sorry. So from team T, we got a team ID, team name, and then we will join it with team mentor together using team ID as foreign key. And then on the mentor table using mentor ID as foreign key. And then we also join with evaluation using team ID as foreign key. So we'll group them by team ID, team name, and also the mentor's name, and we'll order them by descending order of average score of each team. Yeah.
So when we do it, we will get this. So in team 4, right? So we have 4 teams. So team 4 had the highest average score of 24.5, and their mentor was Brian Allen. Yeah, and then as you can see, because one mentor can only can be mentored by more than one mentor can mentor more than one team. So Olivia King actually mentored team 2 and team 3, as we showed earlier. So Olivia King teams respectively got 22.5 and 20.5 for team 2 and team 3. So I think this query is very important because it showcases all the insertion anomalies in business rules and also all the constraints that we have explained earlier in the video. All right, and for the third query, it's a pattern matching and date function query that we were asked to do. So for that, we are listing sessions that a participant has attended. So for this, we have to select the session ID from the pre-event session table, the title of the session, the type of it, date, time, and attended, like did they attend or not, from session attendance, and then we'll join on the pre-event session table. So we use the session ID as the foreign key on both tables. And then we will, where the participant ID is this person, right? So, and then we order them by date and time. So when we run, sorry, I don't know what's happening. Yep, so we will get this. So this session, this title was run by this person. Yeah, so this participant has attended these 2 sessions of workshops. Yep, and that will be the first 3 queries. And after this, Jay will be taking over for the rest of the SQL explanation. Thank you.
Thank you for Dashwin. I'm Jay. I'll be continuing the last 3 query. So let's move on. As you see, this one query is having or and ends. And this query helping us to find the participant who have not attended any pre-event section. We're using a left join between the participants and the section attendance. We filter for case where the attended indicate no, and the rest we consider those who have attended at least one section. We count section attendance per participants, and we categorize them either eligibles or not eligibles. And the result is ordered by the names, and this result is useful for tracking the engagement level before the event. And next, this query is having at least 2 sub-query, and this query is highlighted participant who either register for multiple sections or in a Teams and using a Gmail address. First, we're using a left join between the on both the section attendance and the team membership, and then based on the condition related to the Gmail domain, this one, and register count, which is this one, which means that they are either join multiple section or using a Gmail address. Yep. Here is it. Last but not least, this query is helping to suggest the potential section to the participants. And this query we're using a advanced query using a comment table expression to recommend the section based on the co-participation thread. First, we identified participant pair who offer a tense section together. Then we find the sections where one has a tense but the other hasn't. And this can be used to suggest the section to the participants who share similar interests and potential improving the network and collaboration. And this is showing the data, like the Chris is recommend the develop introduction. And at the end, the Sunford Hackathon 2025 is a large-scale event that demands a well-structured and a scalable data management system, giving the complexity for managing the participant registration, and team formation, mentor assessment, section scheduling, and adjust evolution. Database is essential. So based on this need, we design the ERD diagram to model the data. Then based on the ERD diagram, we create the database. After the setup of the database, we develop the SQL query to support the various functionality. And that's it for this video. Thank you for watching, and peace out.